So yeah, welcome back everyone to more RISC-V graphics programming. So last time we almost successfully drew a bunch of disks in RISC-V. We had some assembly code from the previous time. We kind of rewrote that, and then we got this thing, the screen looking like this. However, that was unexpected since the screen should have been looking like this. I asked about this in the Discord, and Sam, the creator of Serenum and both the operating system and the Brevis language, noted that there's actually a different calling convention going on than what I had expected. In particular, there's basically this kind of summary here that yeah, we really shouldn't be using any of like the first 5 registers. We can certainly use this, but we really shouldn't be touching X8. And so in particular, we really shouldn't be touching the T3 to T6 registers at all. And so I think this is a pretty easy fix to do. Before we do that though, I want to just get something running in the background. I realized that by going into this RISC-V level, we can now implement drawing functions that draw a sprite on the screen given like a binary blob. Doing that in like the simplest way, which is you just provide a local file location for some like image, say it's even like in a QRI form, and then at runtime load that into memory and then draw it to the screen. There's a couple of too many steps in there, so then what I want to do today, or have time to do today. So instead I'm just going to just make like a matrix that contains sort of bytes containing 4 bytes in each entry, just representing the colors, and then we'll write a RISC-V program that kind of draws that to the screen. And then this means we can update what our game looks like with sprites, with some kind of low quality art, but art nonetheless. So to do that, I didn't want to use like Photoshop or whatever the latest totally bloated general software is for that. A Zig user known as Foxan or Foxen made a pixel art editor in Zig, which is really great. That means it's really minimal, and in a number of months we'll be able to build it really quickly because it won't be relying on LLVM for debug builds. And so I experimented with this a couple of days ago. I think it's pretty great at what it does. Like it does the essentials and really nothing else. So I just wanted to like download and have this building in the background while we do our Serenum stuff. So let's make a folder here known as Pixi, and then we'll get this going to here. And then meanwhile we will do our Serenum programming. I swore it was here. Okay. So yeah, this thing does take a while to build, and it also requires a very specific version of the Zig compiler that's not an official release. It's like I think it needs this version here. So yeah, Zig Mac build. I think we can build this. We'll build this with optimizations. Optimize equals release fast. So this will take quite a while to do. So it has to download a lot of stuff. Okay, but yeah, onto the Serenum fixes. So let's see. We want to go into the RISC-V drawings, the codecs, and then let's see, script or edit disk. And so yeah, Sam very generously suggested edits to our procedure here. Namely, to like update T3 with these ones. I think I'm just going to do T3 goes to S3, T4 goes to S4, and then T5 goes to F5. I think that will be kind of easier to remember. We did also use T6 though, and so I think we need to update this to the S6 as well, I guess. So we replace all of the T's 3 and above with S. Replace that. Right. So let's see. We have a T3 here. Now I'm going to have to be super careful with this because the compiler is not going to say anything's wrong whatsoever. Just when we run it, it's going to be stuffed. So yeah, T3 and above we change. Only one T there. Only one T. We're going to go through this line by line. That line is fine. This line is fine. This line is not fine, but it's okay now. Not fine, but okay now. Not fine. 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 Okay. So now let's try and compile this and see if oh, before we do that, one of the other problems I realized I kind of solved. Oh, maybe Pixi has already built. Great. Okay, yeah. So this is working. We'll be using this later if we have time. Okay, but in the meantime, let's copy this. Pixi fast release. What am I doing? Let's move a copy up there. And from memory, like the cache here was really large. Yeah, it's like huge compared to the actual application. Yeah, the actual application is just 12 kilobytes. Yeah. Photoshop, when you make something that's less than a megabyte, I'll then take you more seriously. Okay. So okay, I take that back. It was 12 kilobytes. What I mean to say is when Photoshop is less than a gigabyte, I will take it more seriously. Okay. So yeah, back to yeah. So like in the version that we expected to get, there's no weird like borders around each of these disks, but there is in this case, and that's because in the assembly here, when we're doing the write, we're writing. Oh, I've already adjusted it. It used to be like load, like save long for like 8 bytes instead of just 4 bytes, which is what this word is. So I guess I just automatically did save this. Yeah, so let's try and compile this. It's Control 2, right? Not there. I risk B. then we want to do compile. Well, first of all, this is not correct. The compiler has access to codecs. It is going to use a disk.lbc, and then it's going to write the result to the disk I guess here we want actually disk asm.pv. And yeah, it will compile since we didn't change anything other than the assembly, but will it draw the disks as we expect? Let us see. Aha, fantastic. And it also looks to me that like it's kind of like smoother in some way, almost like it's running faster. I might be fooling myself, but it does look smoother. It's still jittery, but the frame rate seems to have increased, which is great. And yeah, by turning this into assembly and not even vectorizing it, we've got a performance increase, which is good. Okay, so now we can kind of end that. That has been successful. Now I just want to clean up the file so that the draw disk is just purely like the assembly, and we can forget what was previously there. I've also saved a backup copy anyway. So yeah, so this previous version we can get rid of. Yikes, that was silly. Actually, we don't need that one there. So we got that. We got the new main. I think all of this can be massively simplified. There's no need for this to be taking up so many lines. Let's just clear all of these first. Okay. Not as minimal as I would have wanted, but I think this is okay. All right. Okay, so now I want to get on to the drawing a sprite kind of thing. So we'll move back into the current popular operating systems, and but with a new compiler, newish compiler. The software language which pays the most per developer. It was something I like randomly came across yesterday, but I thought it was funny. It was like Stack Overflow. It was like highest wages per programming language. Yeah, here it is. I thought this was quite interesting. Well, it was like interesting and funny at the same time. When you go to work and salary, one of these, where was it? It was the, here it is, salary and experience by language. Where do we get the bar graph? The bar graph is what I want. I guess even outside of the bar graph, it's fine. The higher the number, the higher the salary. And so what's the highest dot? The highest dot is Zig here. So I thought this itself was, I mean, the graph is obviously flawed. Like, how on earth is like PowerShell like a programming language, right? But like, anyway, the very small number of people who use Zig in production at work or are paid by the Zig Software Foundation, yeah. So like, you can simultaneously build an open source project and get decently remunerated. So yeah. Anyway. So so now we've made that. Let's start using it. So we want to do too many windows open. Not needed. Not needed. Not needed. Okay. So software Pixi fast release. Okay. So yeah, so we want to get some like tiles in this game. So I need to remind myself how to make this again. That's right, we need to add a folder first. So we can go into Serenum and say, Serenum Sokoban, and say like sprites or something. Okay. Then we want to do like new how do we do a new thing again? Let's use any palette to begin with. Like the tutorial mentioned to like open something that was already done, but I just want to start something new instead. Maybe we'll just follow the new stuff. Okay. We'll do the tutorial. So the tutorial says go to assets and open up source, and then we can start editing stuff. Like no, from memory there was like a simple way of doing this. wonder if this was like the user guide. To create a new file, right-click the base folder and choose new file. Okay. So we will get rid of that. And then, here we go. We could say Serenum Sokoban, yeah, Serenum Sokoban.pixi. Great. And then this is too large. I don't want this many sprites. Let's like deal with a modest number of sprites to begin with, like maybe 25. Ooh. So like 25, but in terms of the dimensions of these things, let's make this like 10 by 10 to begin with. Okay. Then now we can start drawing. So yeah, so I want to draw like just like a roof tile to begin with. We'll then export this and then use this as the thing to start experimenting with. Okay, so that's like in my head I kind of want something with strong diagonals. It might actually be better for the dimensions of these things to be odd instead of 10 by 10. This may make it a bit of a pain to get things aligned exactly to an image though. Let's see, if the dimensions of these things are 800 by 600, then if we want these to be in the aspect ratio of here's like pick your evil. Do you want to use Python or this? We'll actually go with this for now. 800 divided by what, like, but if the aspect ratio is 3 to 4, then we just want a number that divides evenly into 200. So the only primes in 200 are 5 and 2, so I guess 15. No, but that's like divisible by 3. I guess 25 could be fine. That is a kind of large sprite, but I think we can deal with it. We'll go with 25 then. Okay, so we're actually going to just continue to delete and make stuff. Yeah, just delete this. Just delete it. Okay. So currently we're just going to make an image and then export it as a PNG, convert it to a QNI, process it using our Zig library to just output a file that that Brevis can handle, just to make drawing easier. So it's going to be like almost a ridiculous kind of workflow to begin with, but it's all temporary to begin with. Can we draw lines in this? If I hold down Shift or Alt, no. Okay. This is fine. so much clicking. Okay. We'll be using the bucket very shortly. Okay, and then what's this B? Let's like paste that in here. So this doesn't look good, obviously, but if we adjust, like, how should we adjust the colors here? What are some other color schemes? What about like this, and that? I mean, maybe. This orange is a bit too strong for my tastes. This is also pretty strong. Yeah, like this is temporary, but I'm going to be looking at it for a while. What if it's like these three? Oh, that's a bit too gray. Oh, I see. What if it's these four? What if we then used this? No. Yeah, we might go with... We might just go with this for the time being. Don't want to click as much. Can I do like the bucket on these? No. I guess sensibly it doesn't recognize diagonals. That could be an interesting feature though for the bucket, where you just like toggle on or off if you want diagonals to be accepted. In either case, this is possible for the moment. So, so now we just want to export this selected sprite at usual scale. What's this even called though? It's called new file, and I don't like that. There was some way of adjusting this. It wasn't totally intuitive. In either case, let's move on. Okay, I think that did it. I should add like the Pixi to the path here. I doubt this is not the first time we're going to be using it in the project. Why did I do that? Did that copy? Great. So this is the Serenum, Sokoban, sprites. Ooh, and what was the decent image viewer? Like the only one that doesn't blur when you roll in on sprites. it was like it was a Zig. Was it like Zig image viewer? New file.png. Okay. Good. That is a PNG file. Let's just rename it since, well, we don't even need to we should rename it. New file, let's just call it like roof sprite. Temporary roof sprite .png. Now let's convert it to a sensible image format for game making, QOI format. Oh dear, that looks like a bug in Pixi. Doesn't like the header. What to do now? Instead of like recreating this in Paint, that just sounds evil, even though it would take us less than a minute. Especially since you can, like, I think right click in this and just get all of the numbers. Like, isn't this what every pixel artist wants? Just like the data of these pixel colors. Let's like open this up in Paint and save it and see if that like saves it as like a write file. But I should like, if we had more time, I'd want to look into this and let the developer of the application know. It also may be a problem with, I was going to say Magic K, but I'm slightly doubting that now. Serena Sokoban. Okay, so say we do like save as or something. Now we call this roof.png. Now can I do roof.png? Okay, that did work, great. Zig image viewer, roof.qoi, good, okay. We've now got our QOI file. Get rid of everything. So now we want to just get the numbers of the pixels underlying this. And save that into a format that Brevis can ingest easily. So we can use the QOI processor that we wrote in our Sudoku app. Let's remind ourselves what this was like again. Also, how long have we been streaming? Why is the internet so bad here? This is not acceptable. Okay, just half an hour. $80 a month, and the internet's like that. Not everywhere is North Dakota. So, so we want to do, we want to just browse this again and remember how it works. Luckily, we wrote some tests as well. Okay. So it's just, we get the header by like passing at comp time the stuff where what is, maybe I should zoom in here. Okay, it's, yeah, we just embed the file, that's fine, and then pass it. Then I guess we're gonna have to convert it into, I immediately don't like that, but okay. I wrote the code, it's my fault. Wait, what? Why? Is this actually converting it? Oh, that's right. Yeah, it's because in the QI format, it's only 4 bytes, even though every contemporary system these days just uses 8-byte registers, like for everything. Okay, so we do need to convert that, and then okay, and since we do that at comp time, yeah, we can then just create the matrix we actually want and then fill that matrix up. Okay, great. So let's do that in our case. So we want to do Serenum Sokoban sprites. Let's just make like a new directory here called like QOI to Brevis I guess yeah, Brevis ingest. And then let's just say like roof.z. What would be the best way to incorporate this thing? I guess we can just do, just zoom in on this as well. Let's just include the standard library, but then we also want to import our QOI file. And then, what was the test example again? We basically just want to copy this. So we want to say, in the main, we also need to embed the file. Roof QOI is equal to embed file what was it called? No, what was it called again? Oh, we're gonna have to like go up. Let's just move the roof.qi to QI to Brevis ingest. Roof.qi, and then we say roof header is equal to what does it mean? And we just want to replace RRB header with roof header. But really we want to be the smarter thing to do would be to replace RRB with roof. Okay, I think that's it. And let's just do a crude format here. Debug print standard format dot print. I was gonna do this, and then I remembered we're not programming in Odin. And we just want to print out what the number here is. No. We want to say for every this is what happens when you spend 90% of a day writing grants instead of programming. But the grant is for a lot of money, so it's worth it. Roof pixels, pixel. For every pixel in the roof pixels, we want to just print out the, I think could even try and print it out like this. Okay, let's compile that. Say zig run root.zig. Oops. What? That's right. I think I need to say that. No. What? I feel like I'm doing something really silly. I guess with this I did fail to say that its return type was a void. Why is this failing? Is it because I haven't copied in the QRI file? Fine. Let's do that as well. Which one is it? Here. And then okay, that's in there now. And then what are they? Git build zig run root.zig. Okay, here we're actually getting back to the issue. Undeclared identifier, comp time, header, parser. Oh, I didn't write, since we are calling on our QRI procedures in order to do that. Undeclared identifier pixel. I guess we can just say pixel is equal to whatever the QRI pixel is, which is just 4 bytes. This is very silly. Let's just say this is 4 bytes. Format has no member name to print, really. That's right. It's standard debug. No. Doesn't like the any with the lack of this. Okay, that is what I think. That's what we expect. I'm gonna be like creating such a large file for Brevis. I'm now scared that it might we're gonna run into a compiler bug. But if so, I'll push it up to Sam. And we'll make this bright like 5 by 5 instead. 25. But yeah, this looks right. Like we have this color, a bunch of the same that, and then the next row should be like a different color, the same one. Yeah, this looks good. Okay, so now let's, we want to write this out to a file now. What do we want? We want a file that is itself like formatted in the way in like a Brevis array. So let's see. Let's go back to our actual Sokoban game and check out the syntax for this again. Sokoban. So yeah, if we open up, you go into the codex and open up, I guess it can be not read-only, our Sokoban source code. What have we got? So I think I may want to just manually say like the G matrix here is defined as like fixed matrix 25 by 25. Let's see, G matrix is a variable. Where do we define this again? Up here. Oh, so it's as simple as this. Okay. So I think what will we want this to look like in Zig in the output? In the output, we want several lines of the like this is taking enough time that now I'm thinking, would it actually just be easier to do something different? But we'll continue with this. This is simple to understand. We want to say like G. We want like a line of the form very. I guess I can't do, yeah, variable 25, 25, and 8 sprite. And the actual, and the rest of the lines are sprite dereference ij equals what would be the easiest way to do this? Like we can just set these to be a number, so I think it should be fine. So I think we can just say this is just 256 times, well, Hang on. In Brevis, in this language, like the red pixels are like the smallest. So we want to say like pixel 0 plus pixel, let's try again, pixel 1 shifted by 8 plus pixel 2 shifted by 16. And we're not dealing at all with transparency at the moment, so it doesn't matter. But yeah, the rest of the stuff will need to be calculated. Okay, so let's write that out to let's create a file that has all of that stuff. It'll just be an ASCII file. What's the easiest way to do this in Zig again? Surely in previous projects we've like written to file out to create a file. I mean, maybe not. There should be some just like a simple Zig example of an easy way of doing this. So like Zig writing bytes to a file. Thank you Windows for this completely useless floating thing. Good thing. I'm sure Microsoft's AI is going to solve bugs like this. Thank you, Microsoft. It's so bad. Like they're so bad. Okay. We discovered previously that the easiest way to write a format string in Zig was to like a buffer was like buff print. Where's the documentation again? If it's like lib, I think. No. Is it like lib standard? Like, how do we get to this one again? Okay. Apparently it's just master standard. Okay. It was rough print. Yeah, that's right. So that's where we can just define a buffer and things get put into it. I guess this would be fine. The question is then, that will just give us, that will fill up an array with all the bytes we want. The question is then, how do we get the bytes, that array into a file again? We've solved half the problem. And then we may as well like set this up now. We could say output, variable output is equal to some large number. Let's just say like 10 million. That's too big. What 25 squared is like 625. So if these lines are like at most 30, 600 times 30 is like 1800. So it would be fine if we had it like that, I think. So but it's currently undefined. And then, so then let's say, let's just get this going. Let's get this going. Solve the problem we know how to solve, then we'll check it on we can't. So, print header. So we want to say standard.format.above. Let's just vprint above. Vprint the buffer, which is just our output. Comp time format slice. I guess that's the thing we want to be printing. So we want to print the line sprite. Hopefully that this symbol won't cause any issues. Oh, we're going to have to do this with a loop, which is, what am I talking about? We're doing the easy top line first. Here's the thing, we want like a buff writer. But this is returning a length of the thing, which I suppose we can then like output. Fine, let me just say like current byte index. Set this to be 0. Okay, and then we're going to write to the output to this array variable. I'll just say like spelling error. 25. Oh, I think the Zig syntax has something with this. Right. And then this function can return with an error. So if it does, then immediately fail runtime reachable. But this returns like a line, so we could say like top line is equal to this. And now we just want to say current byte index, increase this by the length of the top line. The top line dot length. I guess that's fine for the moment. So then we could say, before we do any of this, let's see if we get what we expect. A dprint. Output is like really bad. Output buffer. Let's just call it like byte array. Print byte array. Well, we're printing this as a string, and we're printing, let's say, like the first 100 characters. what's the best syntax? Dot 100, I think. First 100 characters of that. Okay, let's get that going. Okay, doesn't like it. 27. Sure, let's convert that to a string. What's going on? Expected tuple or struct argument found void. Right, since we didn't actually put parentheses on that. What's going on? It's at this point that I'm thinking I should just once and for all actually look into string builders in Zig. But I want to just push forward with this. Like, is it this syntax here that's like stuffing it up? Let's say we just wrote variable, and that was it. Well, yeah, and that's literally it. Would this be fine? Nope. Still unhappy. Was I not reading this correctly? Where's like the example? No, there's like none. Args any type, like, yeah, there's no arguments in this format string. Maybe we could just say this is a byte array and treat this as a slice instead. Where's like, how do we do the trace? I saw someone had posted on the in GitHub the like how to do like the back tracing, and they were like, oh yeah, noobs don't know how to do that. I was like, that's me. Like it was Ziglang. What was it? that one's fine. It was like, which one was it? Oh, it was this one here. Yeah, it was just like, that's what you need to do. So, f reference trace. F reference trace. No, okay, okay, apparently that was not it. Oh, it's because it's not a dot there. Damn it. Okay. That's all it was. Okay. Yeah, that's not what we expected. Okay, great. Variable is fine. So now we can test to see what happens. Okay, yeah, this is fine. It is printing that as expected. Good. Spelling error is vague. This should say what actually? Where's the macron again? It's on the A. Okay. Okay, good. So then let's not go through the entire set of pixels. Let's just do like 2. Then we want to say root pixels is just an array, so 25 times I plus the j. That's the pixel, and then we want to format write this. Okay. We want to say buffer print to the byte array. This is where like we want the thing in this form. So we want sprite is equal to blah blah blah, and then this is a number that we're going to be calculating. Well, there's so many things here to calculate, to write. There's the I here, then there's the j, then there's the actual number, and then we need to have a new line. So here we want to say I, j, and then that. And I think that should be fine, kind of, maybe. Make that the line, and then likewise we want to say current byte index plus equals line dot length. Okay. And then we want to print at least what this is kind of looking like here as well. Okay. Oh, we're using an I in like an outer scope? Wow. Previous declaration line 26. Oops. Yep. Type U3. Since when am I setting something to be U3? Huh? why is this saying, why is this saying this? That's like, that feels so weird. Like what? I wonder if this is like a compilable. Like it's probably not, it's probably something I'm doing. Oh, no. Okay, let's just do this the totally basic way. Multiply this by 256. I can't remember what 256 squared is. So we'll do this instead. Why? Clearly U8 cannot represent that. Why does that matter? Because we need to cast stuff. But now we can use Zig's relatively new vector casting abilities. So we could actually say this pixel here is of type, well, we can just say make this, oh no, the pixel here actually kind of isn't a type. Let's just call this pixel basic, is this. And then we'll just say pixel U8 is equal to, well, pixel U8 is better. U8 vec is equal to vector for lots of U8. This will avoid, I think this is the cleanest way to do it. We just have to define this as being that's fine. Pixel, oh, we need to be this is fine. Pixel 1, pixel 2, and then we don't really care about pixel 3, but we'll keep it in here because and now we just want to say pixel U32, and now we can actually do the cast. So now we want to cast this to a vector with what types? I think unsigned 6, people always recommend like signed numbers. Well, yeah, we'll deal with this. As this vector type, we want to cast the pixel. Okay. Which, how many brackets? Oh my goodness. Okay. What does it mean it can't do cast? Is it just like int cast? Okay. I've forgotten. Unused local constant. Okay. Yeah. Okay. No, don't. Using the pixel here was not the right move. We'll keep this that. We'll make this here, and then we'll just replace all instances of pixel here with pixel u8. Except the first one. What is it again? What does this mean? Like no. Valid format string I for u size. Right, since this is actually just D and this is just error union does not support field access. Because I forgot to say catch unreachable. Okay, is this what we wanted? Why is the order of why is the order here getting upset? And why are we not seeing more than one? More than one line getting printed. If we have 1, 1 here, but like 0, 0 is getting overridden somewhere. Are we not increasing this index by the correct amount? Oh, I think it's because, yeah, when we're printing here, we are overriding everything since we're not actually saying begin at the current byte index and go forwards. Okay, that isn't exactly what we wanted either. Surely we haven't run out of like 100 characters here so far. That would just be really bizarre. Okay, or maybe we were. All right. Actually, why am I even doing that? We can just print out the entire thing. Yeah. Okay. Good. Is this what we wanted? Let's just say limit. Let's make this like 5. Yeah, that is what we wanted, I think. Okay. Okay, so now we're printing out. Well, we want to turn this into a file. Can I actually just say output this to roof brevis dot txt? Is that how you do it? No, very much not. I just wanted to side stuff. Well, there's stuff is printing to here, so like there should be some easy way of copying all of this. If I was using terminal click, that would be easy, but alas. No. Come on, I can't even like scroll upwards. This is like the hackiest way. This piece of shit terminal. Okay. Let's just do Brevis .txt. Okay. Done basically. So now now I want to get this into into the Serenum. This said, it's already late. I've been streaming for an hour and 80 minutes, 20 minutes. Why don't we leave it here? And next time we'll load this into the Serenum and then start. Well, what even then? Yeah, we'll load this into the Serenum. Then we'll draw the sprite. We'll do what we did with the disk. We'll write Brevis code that draws this to the screen. Once that's working, we'll then translate that into assembly, not on the Serenum, but using the Venus. It was the Venus emulator, right? And then we'll actually write in that RISC-V code into the Serenum, and then and all of that will be like given something of this form, and then I suppose I guess we should remember this as being okay. It should be fine. Yeah, and then on the Serenum side, we'll just need to figure out how to read a blob, get that into the program, and then we can adjust this program so that it writes out all of the numbers just as like bytes. The image is just a totally uncompressed list of bytes, and then we'll be able to like, yeah, in our game, ingest the blob containing all of the sprites, then draw it to the screen using assembly. Okay, but yeah, otherwise that will be it for today. But yeah, we did a whole range of things today. But yeah, hopefully that was interesting. Thanks to everyone who popped in. And I'm going to be going away, doing yet again more travel. That's what I seem to do for a week. But I'll be back, and once I'm back after that, there will be lots more streaming. Oh boy! Once I get back, there will be 0 grant writing for at least a month, and I plan to make the most of that. So yeah, see you later. Happy programming.